Okay, here we have a pie chart, or now they're actually calling them circle graphs. Um, but we have this circle that's been divided into different parts or pieces, and this one actually lists out a monthly budget. So each one of these partitions here, we can see rent is $750, food is $300, and so on and so forth. We're supposed to use this circle graph to find the ratio of rent to utilities. So again, we want to keep this in the proper order. So we're writing the ratio of rent compared to utilities. So now I can go to my graph and look to see how much is the rent. And that would be $750. Okay, compared to the utilities, which they've told us is $125. Okay, so now looking at 750 compared to 125. Well, if we look at this, we might be able to see what is the largest thing that would possibly go into both of these, or we may not. And it's okay if you know that the top and the bottom both have a 5 in common, then that's okay also. You can always go down by increments of 5 until you reduce it down. Now, if we wanted to do it much quicker, though, we could look to see what is the largest thing that they both have in common. And in this case, 125 will go into 125 one time, and it'll go into 750 6 times. So this will actually reduce to 6 to 1. What this is basically saying is that if we compare rent to utilities, then rent is 6 times what the amount for the utilities is. The ratio is 6 to 1. That's what that's saying. Okay, we can also look at geometrical figures and talk about ratios. So here we have our triangle that's listed out, and this one says find the ratio of the longest side to the shortest side. And so I like these problems because now not only are we having to incorporate the ratios, but we're also having to look at our decimals and remember how do we figure out what's larger and what's smaller. So if I'm going to write the ratio of the longest side to the shortest side, longest to shortest, I'm going to keep that in the proper order. And now I can look at each of these 3 sides and try to determine which one is the longest side. Well, this 25 kilometers would be the longest side. 25 is larger than 24.5. And the shortest side here would have to be the 5. Now I can compare those because these are both kilometers. Those are the same units. Now we always want to reduce fully. So 5 will go into both of these. 5 will go into 5 one time. 5 will go into 25 5 times. So our ratio of longest to shortest is 5 to 1. Now again, we have one more geometry type problem. And again, when they've given us a geometrical figure, and this one says find the ratio of the shortest side to the longest side. So this time we want short compared to long. So looking at each one of our spaces here, it looks like 4 1/4 is our shortest side, and our longest side looks to be 9 1/2. So now that we can compare those, we need to change them over. That would be a little bit nicer. Let's change these to improper fractions. So that would be 1617 over 4 compared to 1819 over 2. And then remember, we do not do this. This is actually a division problem. 17/4 divided by 19/2. But we don't do that. Instead, we change it to a multiplication and flip the second fraction. Now we can do some canceling. 2 will go into 2 one time, and 2 will go into 4 2 times. So when I simplify this, this will be 17 over 38. So this is our final ratio.